Welcome to our video on manufacturing of plastic components. Today, we'll cover the major processes used to shape and form plastic materials into components. The manufacturing of plastic components involves various processes that depend on the plastic's properties and the desired shape. Plastic types fall into two main categories: thermoplastics and thermosetting plastics. Thermoplastics can be repeatedly softened with heat, while thermosetting plastics harden permanently once shaped. This section will introduce the main processes, from injection molding to extrusion, each offering unique benefits for shaping plastic. Thermoplastics and thermosetting plastics have distinct properties. Thermoplastics, these soften upon heating, allowing multiple reshaping cycles. Examples include polyethylene and PVC, valued for flexibility and high-volume production potential. Thermosetting plastics, these undergo a chemical change when heated, hardening permanently, making them ideal for high-strength, durable applications like electrical insulators and appliance housings. There are different types of plastic manufacturing processes. Let's understand them one by one. Injection molding is one of the most common plastic manufacturing processes, particularly for high-volume production. Steps in this process are: clamping. The mold is closed tightly. Injection. Molten plastic is injected into the mold cavity. Cooling. The plastic cools and hardens. Ejection. The part is removed from the mold. This method is known for producing complex shapes with precision, making it ideal for items like automotive parts and bottle caps. Injection molding provides several benefits such as efficiency. It's fast and suitable for mass production. Precision. Ideal for intricate designs with tight tolerances. Minimal post-processing. Components are usually ready for use upon ejection. Common applications include consumer electronics, automotive parts, and medical device housings. Blow molding is a process designed for making hollow plastic parts. Here's how it works. Extrusion of parison. A plastic tube is placed into a mold. Blowing. Air is introduced, expanding the plastic to the mold shape. Cooling. The plastic solidifies as it cools. Ejection. The part is ejected. This method is ideal for producing bottles, fuel tanks, and containers. Blow molding is especially effective for hollow, lightweight parts. Benefits include efficiency. Ideal for large and small container production. Fast cycle time. More efficient than other molding techniques. Applications. Commonly used in making plastic bottles and storage containers, it provides speed and cost efficiency in high-volume production. Extrusion creates long, continuous shapes by forcing molten plastic through a die. Steps include feeding. Plastic pellets are fed into an extruder. Melting and mixing. The plastic is melted uniformly. Shaping. It is forced through a die, creating the desired profile. Cooling. The extruded plastic is cooled. Cutting. It is cut into specific lengths. This process is ideal for producing pipes, tubing, and plastic sheets with minimal waste. Advantages of extrusion. High production rate. Efficient for long, uniform products. Minimal waste. Cost-effective, especially for high volumes. Applications. Often used for manufacturing plastic films, sheets, and structural components in construction and packaging. Thermoforming involves heating a plastic sheet until it's pliable, then shaping it over a mold. It follows these steps. Heating. The plastic sheet is softened. Forming. The sheet is drawn over or into a mold. Cooling. The part is cooled to retain its shape. Trimming. Excess material is removed. Thermoforming is cost-effective for creating large parts, like packaging trays and display units, with low to medium production volumes. Compression molding is primarily used for thermosetting plastics. Here's how it works. Mold preparation. Thermoset material is placed in the mold cavity. Heating and pressurizing. The mold is closed and pressure is applied, causing the material to flow and fill the cavity. Curing. Heat triggers a chemical reaction that permanently hardens the part. This process is suitable for products like automotive components and electrical insulators. Rotational molding or rotomolding is used to create large, hollow plastic parts. Steps are: loading. Plastic powder is added to the mold. Heating and rotation. The mold rotates on two axes while heated, distributing the plastic evenly along the interior surface. Cooling. The mold cools, solidifying the shape. Unloading. The part is removed. This technique is ideal for manufacturing items like tanks, bins, and playground equipment. Rotational molding offers unique advantages. Uniform wall thickness ensures even distribution of plastic. Low tooling costs, more affordable than injection molding. Versatility, capable of producing both simple and complex shapes. Applications include large tanks, kayaks, and industrial storage bins. Film blowing is specific to creating thin plastic films following these steps. Extrusion. Molten plastic is extruded through a circular die. Blowing. Air expands the tube, forming a thin bubble. Cooling. The film is set to its dimensions. Flattening and cutting. The film is collapsed and wound onto rolls. This method is used for products like plastic bags and packaging films. Film blowing provides efficient, high-speed production. Continuous process creates long films with minimal waste. Adaptable produces both single-layer and multi-layer films. Applications include agricultural films, shrink wraps, and packaging films. Blow molding is a manufacturing technique used to create hollow plastic products like bottles and containers. The process involves heating a hollow tube of molten plastic, parisen, placing it in a mold, and using compressed air to expand it to the mold shape. Once cooled and solidified, the finished product is ejected. This method is particularly effective for high-volume production, offering consistency in wall thickness and producing lightweight, durable items cost-effectively. Blow molding has several variations, each suited to different product requirements. Extrusion blow molding is ideal for producing bottles and containers. Parisen extrusion. The plastic is extruded as a hollow tube. Molding and blowing. Compressed air expands the parisen. Cooling and ejection. The plastic hardens and the part is ejected. This process is suitable for high-volume production of containers and bottles. Injection blow molding is used for precision items with excellent surface quality. Injection of parisen. Plastic is injected into a mold to create a preform. Blowing stage. The preform is expanded to match the mold. Cooling and ejection. The finished part is ejected after cooling. Applications include pharmaceutical, cosmetic, and food packaging bottles. Stretch blow molding combines stretching with blowing for strength and clarity. Preform creation. The preform is injection molded. Heating and stretching. The preform is reheated and stretched. Blowing. Air expands the preform to fill the mold. This technique produces strong, lightweight containers, ideal for beverage bottles. Co-extrusion blow molding allows for creating multi-layered bottles. Layered parisen creation. Different plastics are extruded together. Blowing and molding. The multi-layered parisen is blown to fill the mold. Cooling and ejection. The product solidifies before ejection. Applications include containers requiring barrier properties, like food and chemical packaging. Blow molding offers several key benefits in the production of bottles and containers. This versatile process delivers cost efficiency through high-volume production and minimal waste, while ensuring consistency in wall thickness and shape across products. From small bottles to large containers, the process efficiently utilizes recyclable materials. You'll find blow molding applications across numerous industries. In food and beverage, it creates water bottles, milk jugs, and soda containers. The pharmaceutical and cosmetics industries rely on it for medicine bottles and packaging. It's equally vital in producing household chemical containers and automotive components like fuel tanks. However, there are some limitations to consider. The process typically works only with thermoplastics such as polyethylene, PET, and PVC. Complex designs with detailed surface features can be challenging to achieve, and it's not ideal for applications requiring very thick walls. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.